Hello, this is Reza, and today I'll try to go through the assignment tasks, and I'll do them in this order. Where first I show the um the diagram, and then I'll move to the SQL codes, the part three of the assignment, and then I'll try to do the reduction, yeah, from from EORD to the relational schema in SQL. So first, let me start with the ERD here. As the task said, we have basically three entities: course, department, and instructor. Uh, each of them have their own primary key and their own attributes. So I'll start from the department, which is the central entity here. The primary key for department is building name, and it also has another attribute named budget. The reason I chose building name as the primary key here is because well, in every university the department's name is quite unique. For instance, in AUA, so they're computer science, data science, political and governance, etc. So we can take the primary key here because the building name is quite definitive of what the department is for. And then we will move to the course entity. Between course entity and department, there is a relation, as a name belongs here. First, let's go through the attributes of course. Here we had the primary key ID, then we had the course code, which, uh, as the task wanted us, we didn't choose it as the primary key here. It also has description credits and it might have a prerequisite based on the task itself. So let me quickly go through the relation here. I chose the name belongs, and as the assignment asked, a course must belong to one department. So here, this sort of parallel line notation mm, tells us that a course must belong to a department. But in here, we don't necessarily need a belonging relation. And also, we had the cardinalities. So, in my opinion, or like in general, the cardinality here for course and department is both one to many. As for instance, one course can belong to many departments. For instance, let's say calculus in our own university. It's a subject that belongs to both the computer science department and also the data science department. And vice versa, we have a department which can have many courses. Or let me give it a quick bit of thinking here because in this picture there is also one mistake that I made. I was going to change it, but uh, okay. So a little bit of modification for uh, the explanation here. Uh, so here, for instance, one course, let's say calculus, from the rough sketch that I had here. Uh, Calculus can both belong to data science and computer science, and also a department can hold many different courses. For instance, let's say for computer science, we have calculus, database systems, or object-oriented programming, linear algebra, etc. So both of them here have sort of a one-to-many relationship. And then here we move to the instructor part. The reason that my initial mistake was here, which I'll get onto when I discuss the cardinality. So here there is a has relationship because an instructor based on the descriptions in the assignments must have a department. And I mean the word must have wasn't used, but uh, let me read it again. And there are instructors who work in the department. So instructors have a department, and quite vice versa. Department have instructors, and as we can see here, the instructor has a primary key of the ID, the instructor ID. I'll kind of modify when I go through reducing the uh, the the EDR to the relational schema and SQL. So we have the instructor ID, and which is the primary key, and we also have emails and phone number, and we also have the name, which has its own different attributes: first name, middle name, and last name. Like the one before, an instructor can have like one or many departments associated with it. Again, the primary example is our own university. For instance, the professor who, for instance, teaches statistics for computer science also teaches statistics for data science. So that's an example of like one instructor who teaches in two different departments. Here, I made some initial mistake because I thought, for instance, let's say we have a department which has its own name and has its own budget, but it hasn't started like officially working or getting students yet. But it is an existing department, like the one we had of last year in the university, which didn't have initially an instructor, but it existed. It has a name, it had a budget, but it didn't have an instructor because it wasn't teaching it. But based on the descriptions in the assignment, apparently every department have at least like one instructor. That's why I kind of picked picked the one to many. I'm saying that changing it from one to many. Here the relation, because again, one department, two departments can lead to one uh one instructor or have like many instructors. So this is the overall view of the the ERD. Now we can move to the SQL part. Here I have answers of questions one, two, and four because I couldn't wrap my head around the third and fifth question. I mistakenly named part one as part two and vice versa. So I'm sorry about that. I'll change it when for the submission. So for the first question, we had using join writer query to find those courses that require more than two as prerequisites. So first, uh, we select everything that's related to the course table, and we join it using from and course and prerequisites. So basically, join these two tables, and we pick the course IDs which have the same prerequisite IDs. And for the final results, we want to group everything by course ID, like giving the final results as an indicator of the course ID. And here we make our conditional clause that we want the courses that have more than two prerequisite IDs for their counts. We use the count function to calculate the number of prerequisites. And when we run it, I think it doesn't bring up anything. It's zero. I think there is an issue of uh, moving the database to MySQL because I either got null for this part and zero for this part. So I think there was a problem of execution from my part. Then we move to the second part, which is to use the scalar subquery technique in order to find the prerequisites for the given course code, like 958. So first, here we get all the prerequisite numbers and name the prerequisite code. So again, we pick the course ID attribute from course, and we count the prerequisite numbers, and then we got the join here. We join the course and prerequisites columns together to get our uh, initial kind of uh, table to get our results from. Here we make our condition, which is where when the courses who have their own prerequisites, so we want to gather those, and we have the final grouping here by the course. We want to output the name of the courses. So we get the codes here, and then we count everything from the codes that we got here, which have the prerequisite number of 958. So that was for the second question. And the fourth question was finding the courses that don't have the prerequisite using the left join. So again, we pick everything from the course table, and here we make our conditional statement where first of all, we pick all of those who have a prerequisite for them, and then we make them not exist to get the opposite of those, which are the courses that do not have a prerequisite. Then we output that. Now, I'll try to move to the part for reducing the ERD to relational schema. So, moving to the second part, we add the diagram here from choosing file and then choosing a new model. So, using this, we make the first table. Let's say this is the instructor table. We name it instructor, and then we give the columns. I'll pause the video here, finish the diagram, and then uh, so I quickly made the entities in the SQL. So we can see instructor, department, course with their keys, instructor ID, primary key, here building name primary key, and here the course ID is the primary key. Now I want to quickly make the relations between them. So there is one relation between instructor and department. We use the department building name as the foreign key for department. Here we don't necessarily need to do the other way around uh, because there's a relationship. Or wait, okay. Uh, we actually do need to also have department and instructor related to each other and get the instructor ID as a foreign key, because again the department can have multiple instructors, so it is good to have the foreign keys of like each instructor from the instructor ID to sort of get a better and like more precise data of which instructors are working for each department. And also, there is another relation between a department and course, and vice versa. A one to many for both sides, which is basically a many to many. And again, we get the foreign keys automatically. First, we got the course ID as the foreign key in department from course, and also the department building name, which is the building name primary key of department, being changed to a foreign key of the course. name the department building name, and to sort of reduce it to the text, we go. Yeah, let me take a screenshot because I'm kind of confused on what we should submit exactly for part two. We go to databases for word engineer. Mm, Everything set to default. Here mm, we got the reduced form of it. Let me save this one as well. So yeah, this was basically it. We also saved it, and so I will be submitting it, everything in these little bits. Thank you for your time.